Hello guys, I hope you've been well. Welcome back to Manela's Arc. So this will be the first video that I'll be recording for the year 2025. And this video is about exponents, right? And then since it's about exponents, we are going to do a lot of things about exponents, such that I divided this lesson into two parts. This is the first part, and the second part is coming, right? So I'm sure as you are looking at this video, because it will already be uploaded, you will see how much time this one video, which is part one, is going to take from you. So please make sure that you have a paper with you, not just a paper, maybe 8 pages, 10 pages, because when you're watching a maths video, you have to work things out and see if you understand them, because looking at it only doesn't confirm your understanding. So you need to write things down and see if you can solve them yourself too. And yeah, let's on. And then again, for those who are new on the channel, please understand that I make a lot of mistakes on this video, like a lot. And then it makes me happy to see you notice them. So if you ever do notice any mistake, please let me know. Let me know in the comment section, or you can let me know through WhatsApp, so that if the mistake confused you now, I can clarify it for you and accept to you that, okay, this was a mistake on my part. I was supposed to do this and this and that. Okay, right. So for a long video like this, if it was a short video, I guarantee you I was not going to make a mistake. But for a long video like this one, it's going to take a lot of errors. So I want to start this video by us going through some laws of exponents. And then it's my understanding that you guys, you've studied what are laws of exponents. For a person who's in grade 11 now, they know these things. So I'm just going to run through them fast, just so that I can remind you of those things, and then we are sure that you understand them. And then it will be in your best interest now that maybe you have a pen and write them down as you are working on them, so that you can actually refer to them every time we look at the problem. You can just refer to your laws of exponents. Let's start with the first one. The first one says if I have a raised to m multiplied by a raised to n, multiplying powers with the same base, I should add their exponents, right? So I'm running through those things because you know them. And then if I have a raised to m divided by a raised to n, dividing powers with the same base means I have to subtract their exponents. And this can be written this way also. This can be written in the form of a raised to m divided by a raised to n. And then you know that you have to subtract their exponents. Hope we're good there. So another thing that we have is that in exponential laws, whenever I have a power like this raised to an exponent that is outside, I know that I have to multiply the exponents together, right? Another thing that I know is that when I have two bases inside the brackets raised to an exponent m, the exponent belongs to all the bases. So I have a raised to m and b raised to m. Same as when I have a situation of a over b raised to m. The m belongs to all the bases there. The a will be raised to m and the b will be raised to m, right? And then other exponential laws that I know is that whenever I have anything raised to 0, it will always be 1. Such that in brackets, even if I have a binomial, but it's raised, as long as the whole bracket is raised to 0, that is the same as 1, right? I also do know that whenever I have something raised to a negative exponent, I must take that thing and write it down as a denominator. Such that now, if I have a multiplied by b raised to negative n, I should keep a on a numerator level because a has a positive exponent, and then the b raised to negative n now becomes the denominator so that it can have a positive exponent, right? These are the things we know. I'm rushing through them because we know them. Last one, if ever I have an m root of a raised to b, I must take a with its exponent, divide its exponent by the value of the root, this way, right? These are the exponential laws that I think we all know. And then I think it's best, it's not even all of them, but I think it's best that you have these ones next to you, so that when you're going to solve the next problems, you are able to refer back to them. So another thing that we have is the concept of rational exponents. I can ask you to remove something from it being written in a set form and write it only in exponential form, such that it only has rational exponents, right? So let's say we have a number like the cube root of 3 squared. 3 squared is a set. If you leave it like that, or you try to solve it without removing the roots, it's going to remain a set. So what you have to do is that you have to use one of the laws that we spoke about in the previous slide. So you're going to take 3 raised to its exponent divided by the value of the root. That's what I want you to do. Easy, right? Let's try another one, just to make sure you understand. We have 2 raised to 3 here. 2 raised to 3 is also a set. For you to work this out, you must take 2 raised to its exponent divided by the value of the root. Now, what is the root here? If it's a square root, it means the value is 2. Easy, right? So I want you to keep on remembering these things all the time. So if I have the square root of 2, what do we have? I know that my 2 is raised to 1, right? If 2 doesn't have an exponent, it means its exponent is 1. So I take that exponent and divide it by the square of the square root. Easy, right? Doable. Here I have the following. It says calculate the following without the use of a calculator. I have 8 raised to 2 over 3. So now, these things I'm going to try to do them step by step. What do we do? I can see that I have an 8 here. I need to rewrite the 8 in exponential form, and that is 2 raised to 3. That is 8 in exponential form. However, the 8, which is 2 raised to 3, already had an exponent of its own, which was 2 over 3. Now, I need to sort out the issues between the two exponents, because I cannot have 2 exponents like that. This is the same as 2 raised to 3 over 1 multiplied by 2 over 3 here, right? And then if you are new to my channel, here we don't do cross multiplying or cross anything, right? So you're going to have a base of 2. You do them traditionally by saying 3 times 2, that is 6. 1 times 3, that is 3. This is the same as 2 raised to what is 6 over 3, that is 2. I said 2, but I wrote 3. That is 2 squared, right? And then the answer to that, what is 2 squared? 2 squared is the same as 4. Easy, right? Now that was very easy. Let's go on to something now more challenging. So here, guys, here what we are supposed to do, we should take note that we must consider the exponent outside and distribute it to all parts here. So this exponent must be multiplied with the 8, must be multiplied with the a, and with the b. Same thing applies here. This exponent must multiply with the 27, it must go to the a, it must go to the b. So the exponent belongs to every base there. So now here, I have an 8. I'm going to try to show all the steps so that no one here gets confused. So please bear with me if that is too slow for you, okay? So I have 8 raised to 1 multiplied by a negative 2 over 3. I have b with a base of negative 2, but exponent. I want to make this exponent to be like a fraction, because the exponent that I'm multiplying with from outside, it's also a fraction. Wait, I forgot a here. The 8 is so close to a. Okay, I have a raised to 6 over 1. I write it as a fraction, the exponent of a. Then I multiplied with the exponent outside this way. And I have b with an exponent of negative 2 over 1, multiplied it with the negative 2 over 3 outside. This way here. And then what do? And then I do the same thing. What I did on the numerator, I do on the denominator again. So this is 27 raised to 1 multiplied by negative 2 over 3. I have a base of a raised to negative 3 over 1. I multiplied it with negative 2 over 3. I have a base of b raised to 1. I multiplied it with negative 2 over 3. So now what do? I realize that this, no, wait, let's move on. I have 8 raised to 1 times negative 2 over 3, that is negative 2 over 3, right? I have an a raised to positive and negative, that is negative 6 times 2, that is 12, 1 times 3, that is 3. And then I have a b here, negative and negative, that is positive, 2 times 2, that is 4, 1 times 3, that is 3. This way. And then I have a 27. Here's 27. Positive and negative, that is negative over negative 2 over 3. I have an a here, negative and negative, that's positive. 3 times 2, that is 6. 1 times 3, that is 3. I have a b, positive and negative, that is negative. 1 times 2 over 3, that is 2 over 3. There we go. Afterwards, I need to transform 8, that I need to write 8 in exponential form. 8 in exponential form is the same as 2 raised to 3, right? This way. And then I have this thing here. And then here I need to simplify this. This is a raised to, what is negative 12 over 3? That is negative 4. This way. I have a 27 raised to, wait, I need to rewrite the 27. 27, if I express it in exponential form, that is the same as 3 raised to 3. And the 27 had an exponent which was negative 2 over 3. We good. And I have an a here. What is 6 over 3? That is the same as 6 over 3. 2. Yes. And then I have a b here, raised to negative 2 over 3. It's just a lot of things to say. That's why I keep on making mistakes in saying them. So now I have this thing here, 2 raised to 3. I'm multiplying a whole number with a fraction, so I also need to make it a fraction. And this one I'll also make it a fraction, right? So that means now, start with the 2. I need to take things step by step so that I don't make a mistake. What is, let me check something, okay. What is positive and negative? That is negative. 3 times 2, that is 6, over 1 times 3, that is 3. Next part. I have a raised to 4. And then this a now in this situation, I'm dividing this a with this a here. What happens when I'm dividing powers with the same base? I subtract their exponents. So which means this exponent 2 will go above as a negative 2. Right? Same thing applies here. I have b powers with the same base, which is b raised to 4 over 3. And then I'm subtracting this part. So if I send a negative 2 over 3 above, by the time it gets here, it will be positive. This way. And then all this is over this denominator here, right? What is this denominator? Here I have a base 3. What is positive and negative? That is negative. What is 3 times 2? That is 6. What is 1 times 3? That is 3. See, how's that? Then I continue simplifying. I'm going to have 2 raised to, what is negative 6 over 3? That is negative 2. What is a this? That is a raised to 2. What is this one now? This will be equals to b, right? Raised to 4 plus 3, 4 plus 3, 4 plus 3. Same denominator of 3. 4 plus 2, that is 6. I don't know why was I saying 4 plus 3. Right. Oh, the 4 here is negative. I missed that. A raised to negative 4. So the 4 here is negative, which makes this negative 4 minus 2. Here it is here, negative 4 minus 2. That makes this now not negative 2. Instead, this is, see if I can fix that. Negative 4, negative 2, that is negative 6. I don't know how I missed that. Okay, it's fine. Denominator here, I have base 3. What is negative 6 over 3? That is negative 2. Hope I'm good now. So one thing that I'm also realizing here is that some things are in places they are not supposed to be. As long as something has a negative exponent, it's not supposed to be there, right? So b raised to 6 over 3, it's the only thing that has a positive exponent. That's the only thing that deserves to stay there. Everything else needs to switch positions. If it's a numerator, it needs to become a denominator. Denominator needs to become a numerator for as long as they have negative exponents. Let's do that. I have a 3 that was raised to negative 2. I make it a numerator now with a positive exponent. Division line. I have a 2 raised to negative 2. I make it a denominator now with a positive exponent. I have a raised to negative 6. I make it a denominator now with a positive exponent. I have b raised to 6 over 3. It stays on its level. And what is 6 over 3? That is 2. Simplify. Now we are at the final stage. 3 squared, that is 9. B squared. 2 squared, that is 4. A raised to 6. Final mark. Whew, that was a lot of talking, but we got here now. And I'm happy that we did it. We can move on to the next question that is similar to this one. So here we have the following. We still have to simplify the fraction, right? So this is how we're going to do it. Firstly, I can see that I have same basis, right? I want to rewrite this set in terms of it having rational exponents. So x raised to 5. When I remove the square root, I'll be dividing this by 2, right? And then the multiplication, I'll represent it with a dot. Here I have an x. What is the exponent for x? It's 1. And if I remove the root, then I divide by that value of the root, right? And then I have 5 exponent for 5, I have x exponent, which is 5. When I remove the root, I have to divide that by 6, right? And then afterwards, I realized that I have same basis and I just have to deal with the exponent. So I'll do this step by step again so that people don't get lost. I'll start first by multiplying the numerators. So I have x. Why is this thing such a tongue twister for me? I have x raised to 5 over 2. I add the exponent 1 over 3. All this is over x raised to 5 over 6. Then this is going to be what? This is going to be x raised to. I have the 5 over 2 and the 1 over 3. I need them to have the same denominators. So 2 and 3 will have the same denominator at 6. So I'll multiply this by 3 over 3. And then here's the plus sign as you see it. I have the 1 over 3. And then this 1 over 3, I also need to multiply it by 2 over 2. All this over 5 over 6, right? Then I'm going to have x raised to 5 times 3, that is 15, over 2 times 3, that is 6, plus 1 times 2, which is 2, and 3 times 2, which is 6. Now I have the same denominators. I can just add the numerators. I have x raised to 15 plus 2, that is 17 over 6. And this is divided by 5 over 6. I'm doing this step by step. That's why it's taking time. All right. And then now I'm dividing powers with the same base. So I'll have x raised to 17 over 6. That is the numerator. That numerator, now I'm going to subtract the exponent of the denominator, which is 5 over 6. So I already have the same denominators for the exponents. I can just subtract the numerators. 17 minus 5, that is 12 over 6. Now simplifying this further, what is x raised to 12 over 6? That is x squared. This is the final answer. Not too bad, is it? So those are the things I wanted us to work with just to prepare ourselves to get into this topic of exponents, because we have more difficult things to work with. So here we have the following. Here we need to simplify these expressions, and this comes with a few tricks with it. Now what I need you to understand is that so far we have 5 raised to x, 9 raised to x plus 1, 3 raised to x plus 2, 15 raised to x minus 1. We have these values that have different bases, but in their exponents, I see that they have something common, which is x, right? So now in that situation, what I need us to break the exponents apart. So I need to isolate x, and then after isolating x, then I can go to the next step. I'll tell you the next step. Let's focus on what's important for now. So this is 5 raised to x. The exponent is standing alone. And then here I have 9 raised to x plus 1, which is the same as 9 raised to x multiplied by 9 raised to 1. That's an exponential law, right? If I multiply these bases with the same exponents, I'll be adding them together to be like this. So now in this situation, my first step is to break this down into its different components. Same thing applies to this 3 here. I will have 3 raised to x multiplied by 3 raised to positive 2, because we have a positive 2 there. Then here's a multiplication sign. I have a 15 raised to x multiplied with a 15 raised to negative 1. This way. So now our exponent x is no longer attached to any number here. Now the second problem. The second problem is that I have base 5 here. I have base 9 here. I have base 9 here, base 3, base 15, base 15. I have 4 different types of bases. I want to reduce that to the smallest number of bases that I can have. So this base 5, I cannot rewrite 5 to be in any form. So it will stay like that. 5 raised to x multiplied by. And then this base 9, I can rewrite this so that it becomes in terms of 3 raised to 2 in a different exponential form. So I'm rewriting that now as 3 raised to 2. Easy, right? And then it had an exponent x. So that exponent x needs to be multiplied now with the exponent of 2 there. Easy, right? So the 9 is now 3 raised to 2. The x, it's still here as an exponent. Multiplied by. In this situation, because this one doesn't have an x. Okay, let's convert it. This one is going to be 3 raised to 2. I'm converting this one too also. Right. So 9 is the same as 3 squared. Okay. And then here I have 3 raised to x. There is nothing I can do to the 3 here. This is 3 in its simplest form. And then here I have 3 raised to 2 already. So it's simplified. Multiplied by, and then I have a 15 here. So far I can see that I'm playing around bases of 3 and 5. 3, 3, 3, and 5. Right. So this 15 now, I need to re-express it. But however, I cannot write 15 in exponential form, like 3 squared, the way I did with 9. Now I need to write 15 as a product of 2 numbers. What do we do there? So what I do, I'm going to say 15 is the same as 3 multiplied by 5. Easy, right? And then the 15 already had its own exponent, which was x. So that 3 times 5, I'm going to attach it to x outside the brackets, right? And then the same thing applies to this situation here, where there is 15 on this part here. I'm going to replace that with 3 multiplied by 5. And then the exponent that was allocated to 15 as negative 1, I'm going to put it here. Let's extend the division line there. Now, what else is going to happen here? From here, I want to deal with the denominator part so that I can remove the brackets. Let's do that. I have 5 raised to x multiplied by 3 raised to 2x multiplied by 3 raised to 2. This is the same as I have 3 raised to x multiplied by, I have to distribute the x into the bracket, so that is 3 raised to x, and I'm going to have again 5 raised to x, and then here I'm going to have 3 raised to negative 1, and then here I'm going to have 5 raised to negative 1 because the exponent is being distributed. Hope we're good there. So now what I want to do is that I want to take everything that has, let me do it this way. as you can see, I want to take everything that has a base of 5 and attach it to this. This will be the main base for 5, right? So everything with base 5 must go there. So here's another thing with base 5. Here's another thing with base 5. All of them, they'll follow this one. This is the main base, right? What is that? That is 5 raised to x, as you see it there. And then I have to take this exponent upwards to that. So if I take the exponent upwards, it becomes a minus exponent, right? And then here, if I take a negative exponent upwards, it becomes a positive exponent, like that, right? I'm done with all the 5s. Now I go to the 3s. So here is base 3. Oh, this is not visible. Does yellow work? Here's base 3. Yes, it works. Nice. Here's base 3, base 3, base 3. Right. So what do I have there? I'm going to have this first one as the main base. This is the main base, right? That is 3 raised to 2x. And then this one, if I attach it to that, they are only joined by multiplication. So if they're joined by multiplication, we add the exponents, right? And then afterwards, I take this part here. I send it above. What will I have? I will have negative x. And then I'll also take this part again. I send it upwards. What will I have? I will have negative x again. And then I take this part here. I send it above also. This negative 1 will now become positive 1. And then I solve these things out now. This and this will cancel out. I'll be having now here 5 raised to 1. And then in this situation, these things here are like negative 2x. So negative 2x and positive 2x, they cancel out, right? I'll be left with 3 raised to 2 plus 1 there. And then what do I have? My answer is going to be 5 multiplied by 3 raised to 3. What is that? That is 5 multiplied by 27. And then using my calculator there, 5 multiplied by 27, that is the same as 135. That is simplified. I took a long step around it, but I hope you understand the process behind it. Why did I do the things that I did, right? So let's move on to the next part. Here's the next one. And then on this one, I want to show you that there are different ways you can solve expressions. But as long as you can get to the answer and you use the correct mathematical principles, then that's great with us. We have base 3, base 18, base 6, base 9. So we all can see we have 4 different types of bases. So we need to re-express these things. So this is in the form of base 3, and there is nothing I can do to this base to make it more simpler. So it will stay like that. And then I have base 18. This is the same as 6 times 3. Let me start with that. 6 multiplied by 3 raised to x. Right. And then I have here 6 raised to x. 6 raised to x. Boom, boom, boom. Plus 1. And then here I have what? I can rewrite this in terms of 3. So I'm not breaking it apart now. I'm writing it as it is. I'm going to say, let me choose a different color so that you can see it. I'm going to say this is 3 squared. And then the exponents, I'll keep them outside here. You see that? So what do I have now? I have 3 raised to x plus 3 multiplied by, I bring the exponent inside here. That is 6 raised to x multiplied by 3 raised to x. You see that? And then I'm going to have here 6 raised to x. I feel like breaking this one, but let's take it as it is. And 6 plus 3. You could have broken it down like we did in the previous example. I just want to do this one with you without breaking it down. Multiply this by, I have to distribute this now to all the numbers because I'm multiplying a whole number with a binomial. That is 3 raised to 2x plus 2. Don't forget to multiply the 2 with the 1 there, right? 2 times x, that is 2x. 2 times 1, that is 2. And then what do I have? I need to send things above now. So this will be my main base for all the 3s, and this will be my main base for all the 6s, right? So I have a 3 raised to x plus 3. When I bring this base, this 3 raised to x, that x will multiply, this power will multiply with this power such that I add the bases. And then when I take this above, I'm going to say minus this binomial exponent. When you're subtracting a binomial exponent, you put that binomial in brackets this way, right? And then this is multiplied by the 6 that you see here. Let's write that with a different color. So for all the 6s, here we go. This is the main base 6, so that is 6 raised to x. I bring the base above also, the exponents above, such that I'm subtracting a binomial, that is x. Is it visible? Let me save this. I think it's about to crash. Okay. Oops. This thing is okay. I think we are back online now. I said this is 6 raised to x. Here is 6 raised to x minus a binomial. Here is that binomial. So, and then I have x plus 3, that binomial there. And now let me divide this and continue there. I have here x and x, those things, they add up to 2x. So that is 3 raised to 2x. And then this 3 here, I'm going to put it here. It's positive 3. And then here I want to remove the brackets. I distribute the negative 1 into the brackets. Negative times positive 2x, that is negative 2x. And then negative times positive 2, that is negative 2. Then we move on to the other part there. Multiplied by this, I have 6. This x is standing alone, so I'll just make it stand again. And I distribute the negative 1 into the brackets. Negative times x, that is negative x. And then negative times positive 3, that is negative 3. Simplifying further, the positive 2x and the negative 2x will cancel out. I'll be left with 3 raised to 3 minus 2. And on this part here, the x and the negative x will cancel out. I'll be left with 6 raised to negative 3. And then with that, I'm going to have here 3 raised to 1 multiplied by, this has to be a denominator now. So I have to take it down so it can have a positive exponent this way, right? So now the numerator is already sorted, that is 3, we know that. The numerator is equals to 3, and then 6 cubed, that is going to be 216, right? So if 216 is divisible by 3, you divide it by 3. I just checked for myself now, it is divisible. So I'll have to divide this part here by 3 and also divide this part here by 3. What does that give me? That gives me 1 as a numerator and it gives me 72 as a denominator. So that's my final answer. I hope the process makes sense. I hope you were able to pause this video and try this question on your own before you proceeded to see the answer. And yeah, I hope it lands. Let's go to another one of multiplication and division of exponents. But the next one, you must be able to pause and see if you can do it. Here we go. Assume that you got this question in the test, then you have 7 minutes to solve it. Try this question on your own to see if you can do it before you proceed to see the solution. So here what I'm going to do is to rewrite 8 in exponential form. So that 8 is going to become 2 raised to 3. and then everything else stays like how it was supposed to be. These exponents, I'm going to have x minus 2 in brackets, and then I'm going to have the square root like that. Right, this is the 2 raised to 3, that is 8, and in these brackets I'm keeping this binomial exponent that was already there, right? And then here I have the cube root of 9. I'm going to rewrite 9 now in terms of 3 squared. So since the 8 already had an exponent x, I'm going to multiply x with the 2 such that it becomes 2x. There, right? Go into the denominator. I have a cube root there. I see I have base 2, I have base 3. I don't have base 6. So can I write 6 in terms of 2 and 3, or 3 or 2? Yes, I can write it in terms of both, right? 6 is the same as, I'm going to say 2 multiplied by 3, right? And then afterwards, that 6 had an exponent, which was 2x minus 9. That whole thing is an exponent. Multiplied by, this is base 2. So this is as simple as it can be, right? 2 raised to negative x over 6. Afterwards, then I distribute the exponents where they are brackets, step by step. So 3 times I have base 2, 3 times x, that is 3x, 3 times negative 2, that is negative 6. This is under a square root. And then this is multiplied by, I have 3 raised to 2x. So this is the same as me having base 3 raised to the exponent 2x divided by the value of the root, which is 3. And then here I have the cube root. 2 times 3 have these exponents. I'm going to take the 2, give it the exponent, the whole exponent, and I'm going to take the 3 and also give it the exponent. Remember, you have to distribute the exponents outside into all the values inside the brackets. And then remember this, we said it is as simple as it can be. Easy, right? Afterwards, I want to remove this square root here that's in front of the 2. So I'm going to take the 2, and I have 3x minus 6, the whole thing, the whole exponent, I divide it by the value of the root, which is 2. And then this is multiplied by 3 raised to 2x over 3. After that, I have to do the same here. I have 2 raised to 2x minus 9 all over 3 multiplied by 3 raised to 2x minus 9 also all over 3, because that was also under a square root. And then I have this last part here, 2 raised to negative x over 6, right? This is going to be a long problem the way I see it. So I break the fraction here. This is 2 raised to 3x over 2 minus 6 over 2, right? That's what it means here, right? Multiplied by 3 raised to 2x over 3, all this over 2 raised to 2x over 2. Am I right? No, sorry. It's another way around. This part here, I think I need to write things in different colors. Let me write the denominator in a different color. I have a 2 raised to 2x over 3 minus 9 over 3. Multiply this with base 3 raised to 2x over 3, and then minus 9 over 3 multiplied by 2 raised to negative x over 6. See that? So then comes that part. There comes that part now, whereby this will be the main base for all the 2's, and this will be the main base for all the 3's. So here's a 2 here. Let me circle the 2's. So I need to align this to one base, which will be this one. So this 2 comes first as the primary base. So I have 2 raised to 3x over 2, right? Minus 6 over 2, which is here. And then afterwards, I take this binomial upwards, which is minus 2x over 3 minus 9 over 3. I put a minus for this whole exponent in brackets so it can go above, right? And this one was negative, so I'm going to make it positive x over 6 multiplied by, let's not forget we have another base here, multiplied by, I'll write it down there. This is the main base for all the 3's, and these are the 3's I have. So that is 3 raised to 2x over 3 multiplied by 3. Sorry. What am I doing? I have to send this exponent above to the main base, right? So that is minus this binomial exponent. I'm going to put the binomial now in a bracket this way, right? So let me create some space here on the left. So now what do I have? Let me deal with the 2's, right? So I need to take things outside the brackets, especially in this situation. So let me fix this. I have base 2 raised to 3 over 2. And then this is the same as negative 6 over 2, that is the same as 3, right? And I have this negative multiplies into the brackets this way. Negative times this, that is negative 2x over 3. And then this is negative 9 over 3, right? So if this is 9 over 3, it's the same as 3, right? And I have a negative and a negative, which now becomes a positive 3. These are exponents, bear in mind, right? And afterwards, I have the base 3's. In terms of base 3's, what I have is 3 with 2x over 3 minus this multiplies to that. I have 2x over 3. That is not even visible. Let me fix that. I said 3 raised to 2x over 3. And then this is a minus. I have 2x over 3, which is here. And then this negative times this negative, that's a positive. 9 over 3 is the same as 3, right? So now, moving on. Oops. Oh, I thought it crashed. Almost crashed. So here, I'm going to have this 3x over 2 cancels out. It doesn't. Oops. I need to make the denominators the same. So the 3x over 2 and the minus 2x over 3, they need to have the same denominators. And the negative 3 and the positive 3, they cancel out, right? And then when it comes to the denominators now, what do I have? I have a base 3. There it is. The 2x over 3 and the 2x over 3, these ones, they do cancel out. And I'm left with a positive 3 there, right? So let's solve further. These ones, what they need now, they need to have the same denominator. So I have 2 raised to 3x over 2. I need to multiply this with 3 over 3. And then here is this subtraction sign. I have a 2x over 3. I need to multiply this now with a 2 over 2. And then I have this 3 raised to 3, which is the same as 27. So with the 3's, I'm done. I need to get this thing sorted with the 2's, right? So I have what? I have 2. 3 times 3, that is a 9x. 2 times 3, that is a 6. Minus, I have a 2x and a 2x. I have a 2x multiplied by a 2, that is 4x. 3 times 2, that is the same as 6. And then we multiply this with a 27, right? And then what do we have? We have 9 minus 4, which is 5x. All this is over 6. Multiply this with 27. There we go. If I might have made a mistake somewhere, please forgive me, but this is where I learn. Doable, right? Just have to follow a lot of steps. A lot of steps. That's the thing. So on to the next one. So here we have the following. What is different from this one to other ones is that this one, it has a binomial as a numerator. It doesn't have a monomial. So previously we used to deal with questions that have multiplications in between. And then now we have this one that has a subtraction in between. Now this one definitely requires factorization, and you cannot shortcut your way around it. So let me get to it straight, and then you'll solve the next one. So here what I want to do is that I need to break this fraction so that the x is isolated. Here I need to. So I have 3 raised to x. I have 3 raised to 1 multiplied by 4 with 3 raised to x and 3 raised to negative 1. This one, I hope you are able to do it. Hope there are no issues there. There's no need for me to explain. So here I have 3 raised to x multiplied by 3 raised to negative 2, right? And then what happens there? From there, I realized that, wait, this binomial has a 3 raised to x here, and it has a 3 raised to x here. So that 3 raised to x is, in fact, a common factor, right? So, and then if I take out the 3 raised to x here, what am I left with? I'm left with 3 raised to 1, which is just 3. And then here, what am I left with? I'm left with a 4 multiplied by a 3 raised to negative 1, right? Close bracket. Now, hold on. With this 3 raised to negative 1, I just want to simplify it. I don't want to work with this now. So, right? So, I'm just going to say that 3 raised to negative 1, my friend, I'll put it as 1 over 3 so that I know how to move forward, right? And then if, okay, I'll move forward with this. It's much easier this way. Let's not skip too many steps. And then here I have 3 raised to x multiplied by 3 raised to negative 2. So the 3 raised to x can cancel out with the 3 raised to x on the numerator side. Right. So, and then what? Then I have 3 minus 4 over 1 multiplied by 1 over 3. And all this is divided by 3 raised to negative 2. Right? And then what do we get? I get a 3 here minus 4 over 3. And then all this divided by, what is this now? 3 squared. I mean 3 raised to negative 2. That is 1 over 3 raised to negative 2. Right? But then it looks somehow here. I need to get it fixed. Right? It looks somehow when I have 3 minus 4 over 3. So I'll just say, for the sake of it, this whole division line, I'm going to represent it with the division sign. But this division line was for everything above there. So this division sign must be for everything above here, right? And then this 1 over 3 squared, I'll write it here, 1 over 3 squared. Make sense? So I don't have to deal with fractions over fractions. They get confusing. So instead of dividing by this fraction, I'm going to write divide by this fraction on the side. It's much easier that way, right? And then what do I have? This is the same as 3 over 1 minus 4 over 3. And then this brackets here. This division sign, we cannot divide fractions. We can only multiply them. So I multiply, and then this becomes 3 squared over 1, right? And then what do I have? Let me get some same denominators here, right? So this is 3 over 1. If I wanted to have a denominator of 3 as my LCM in this situation, I have to multiply it by 3 over 3, right? And then continue with what's happening. Multiplied by, what is 3 squared? That is 9 over 1, right? And then what do I have? I'm going to have 9 over 3 minus 4 over 3. All this is multiplied by 9 over 1. Right? And then 9 minus 4, that is 5 over 3. And I'm still multiplying this with 9 over 1. What am I getting? I'm getting 5 times 9, which is 45. divided by 3. And then 45 divided by 3, that is 15. Not too bad, is it? This was a nice one. This was a nice one. I'm going to give you the next one. Please pause the video and try it on your own before you proceed. So you should just find a way, like you see what I did here. I took the two terms and I was like, oh, common factor. What is common factor? Common factor is factorization. So I saw this thing, this binomial here, that I can factorize by taking out a common factor. So that's what you're supposed to aim to when you have a binomial. Find a way you can factorize and cancel things out. Guys, I think this is nice. Please try to see if you can solve this on your own first before you proceed to see the solution. Pause the video and try it. Right. So I'm going to move on here. Here we have, I see I have base 2, I have base 4. And I want to separate things like I told you. Right. I need things more or less to be the same. So let me break these fractions. Let me break these things apart. Let me see what happens. So I have an 8 here. I'll say 2 raised to 3 just to see what happens. Maybe I might not need to do that. And I have 2 raised to x here. Multiply that with 2 raised to 2. Right? Okay. And then what else do I have? I see here that I have 2 raised to x multiplied by 2 raised to 1. And then here 2 raised to 2. Right. And then what am I seeing now? I see that here I can take out 2 as a common factor here. So I take, in fact, how many 2's can I take out? Here I have 3 2's. Here I have 2 2's. Right. So now I'm going to say here I can take out 2 2's here and I can take out 2 2's here. So this is my common factor. I'll be left with a 2 here minus 2 raised to x here. Right. And then let's wait for it to load. Oh, come on. Come on, this is taking time. Okay, perfect. And then here I have to take out a common factor 2. So my common factor is a 2 and a 2 here. So, but I can only take out 1 2 here. So I'll say 2. And then I'll be left with a 2 raised to x. And here I'll be left with minus 1. Oh, minus 2, sorry. Oh, that almost got me confused. I have 2 2's here. So if I take 1 2 out, I'll be left with 1 2 there. Makes sense, right? Here I took out 1 2. Here it is. Here I'm taking out another 2. I'll only be left with 1 2 here. Now it's better. So now the difficulty here now is that the signs are different. So I need to make them to be the same. So on the top bracket, I'll take out negative as a common factor. And then I'll be left with a 2 raised to x that is positive. And this one, if it was positive, it will now be negative. Right. And then here I have a 2 below, 2 raised to x minus 2. And what do you see there? What I see is that I can cancel things out. I can cancel this and cancel this because the brackets are the same. And then what am I left with? I'm left with a negative. Negative 2, the negative and the 2, they are not all squared. Only the 2 is squared here. So I'm going to say 4 because 2 squared is 4. And then this 2, I'm going to put it here. What is negative 4 divided by 2? That is negative 2 as your final answer. I feel like you don't see it. The answer is negative 2. Much better. See how easy was that? Now, every time you're working with fractions that have addition and subtraction, will you always take out a common factor? No. You'll use any method of factorization that is applicable at the moment. Now, look at the next example here. So, here. This example here, I'm going to call it the let k example. The let k example. Now, what is a let k? In a situation where you have to let k, you will know that you'll have to let k, right? So now, I'm looking at this thing now here. I'm like, okay, how do we simplify this? It's different from the other two that we did. By the way, this is the last example, by the way. So I'm like, how do we simplify this? Because I mean, the other two were not like this. Here we have a trinomial as a numerator. And if we do have a trinomial, well, that should ring some bells into your mind that, okay, I said that you should solve these things by factorizing. And if your numerator is a trinomial, then probably if you have to factorize, that will be by a quadratic trinomial type of a factorization, right? So let's do that. I have x raised to 2 over 5 and I have x raised to 1 over 5 here. Well, how do we deal with those? Well, x raised to 2 over 5 is the same as x raised to 1 over 5 multiplied by x raised to 1 over 5, because when you add these exponents, you're going to get 2 over 5, right? And I have plus x raised to 1 over 5 minus 2, and then here I have x raised to 1 over 5 minus 1 here, right? So now I want to put a method that I'm going to say we want to replace this power. This power looks complex for us. It doesn't make things easy for us. We're going to replace this power with a k, because if I call this whole thing k, it's much easier to refer to it. Like this is k minus 1. You see, it will be much easier for me. So I'm going to say this is k multiplied by another k plus a k minus a 2 all over what? K minus 1. So you see how it is now. Now it looks soft to the eye, like even the brain can interpret something like this. What do I have here? K and k is the same as k squared, and then plus k here minus 2 all over k minus 1, right? So now this numerator now looks factorizable. I can factorize it with quadrinomial this way, right? Factors of k squared, I have k and k. If this 2 is negative, it means the brackets will have opposite signs. Factors of 2 giving me 1, it's 2 and 1. So if it's 2 and 1, which one is supposed to be negative for me to get a middle value of a positive answer? Let me save this document so that it doesn't crash, because I'm almost at the end. Let me wait for it. I hope you're thinking. Factors of this thing that can give me a positive 1 here, it means the 2 is supposed to be positive. So I'll make 2 positive and I'll make this one negative. So k minus 1, you see that? Now I see that this is cancelable with this one, but you cannot cancel something that is not in bracket if it's a binomial. So I want to put it in bracket so that now I can cancel it. And then what am I left with? I'm left with k plus 2. K plus 2, there's no equal sign, sorry. K plus 2, right? And then I return what I borrowed, because this question didn't come to me in the form of k's. I need to return it to what it was. So what it was is that before I threw in my k things, that number was x raised to 1 over 5. So I replace this back to what it was, and then plus 2. This is my final answer. See how beautiful is that? So that is the last thing from me. I'm happy that this thing didn't cross an hour. If you haven't subscribed to the channel yet, please subscribe and like the video, and please tell me if you have any comments about anything, any mistakes that might have occurred. And this is all of it for now. I'll see you in the next video. We are halfway through this now.